Okay, we're back. I guess this works. Would you guys like the kind of setting where you see what's coming up next, or you just want the full one? Your preference? Like here's one option where you kind of see what's coming up next. Does it make a difference to you? You're awake. Okay, good. You're awake. I'm glad you're awake. Um, okay, we'll try just the one we swap on. All right, so here we go. Moving on to the next chapter, chapter 20, inference about a population proportion. So again, not so bad, same kind of concepts as you've seen before in this course. Yeah, we'll do it that way, okay? All right, so you've seen these formulas before, right? Where you have a point estimate, x bar, with some confidence interval, and then, of course, the test statistic that kind of follows from that for appropriate test of significance. And then when sigma was unknown, you use the so-called t-distribution, okay? And so then now when you have two different means, like chapter 19, I think it was, yes, chapter 19, where you had like Rolling Stones, Coldplay, that sort of thing. You look at the difference in the sample means, plus or minus some t-score times the standard error, and then of course you look at the t-statistic there. Notice what you're going to have is pretty much your standard error appears to the right of your critical value, and then it also appears in the denominator of your test statistic. And it's just like our old friend, you take your observation minus what you expect it to be divided by a standard deviation. So it's still a z-score-ish or a standardized observation in disguise. Okay, and so then now what we're going to do here is look at the sample mean, and up through chapter 19, we compared it to some population mean mu, right? And so we're going to write the word mean because that's what that pertains to for our purposes. And then, of course, if you're trying to compare a percentage to a population percentage, then you look at the so-called proportion of successes. So for the rest of this term, we're talking about percentages, percent of people who smoke, percent of people who who favor us attacking Syria, although that issue is long gone now. But anyway, looking at percentages. So all the mean work was before chapter 20, and then now proportions would bring us home until the very end. And chapter 25 will not be on the final, will not be covered in this class. We're going to stop at 23. And so you've seen a familiar friend from days gone by, all right? You're probably tired of seeing this data. It was in your recitation, it was in your notes, but again, it's relevant, okay? Because we're going to still do analysis on proportions. So we can't quite find the average here. The average of a current smoker and former smoker, not so much, okay? But we can look at the proportion of people who volunteer or who currently smoke for different classes. And you've seen this data set somewhere recently. Boo. Okay? Or you saw some variation thereof. All right? So, let's see here. Let's just make sure you remember this type of issue. What will be the conditional probability of being a current smoker given that you're from the upper class? What percent of people who are in the upper class are current smokers? This is a chapter, 5, 6 kind of question. How can you figure that? Now, I know some of your names because you turn in tests to me, right? Right, Ramara? Right. Okay. So, Ramara. Oh, shoot. Okay. So, Ramara, we have 356 students or 356 volunteers, right? But I'm saying, if I know someone's from the upper class, what percent of them currently smoke? Which fraction is that? 51 out of 211. Correct, right? Okay. So 51 out of 211, right? And then, let's see here. Is Kelsey here? No. Okay. How about Ryan left? Okay, he's gone. Let's see here. If I was asked for, if I know someone from the lower class, Mr. Decker, what percent of the lower class folks are current smokers? Oh, did he leave? I think he was just here. All right. Let's see here. Caitlin, is she here? Now, some of you are probably like, if you don't say your name, if you don't respond, then he won't call on me, even though I called your name. Okay. About Brian. Uh-oh. He's bad. Your name again, ma'am, in the hat? Gail. Gail, what's your last name? Connor. Okay, let's go with Gail. All right, so Gail, of the lower class persons, what percent are current smokers?
Wouldn't that be
43 out of 93, right. Okay. So what we can do, that's a 9. That's a 9 right there. So in this chapter, we're going to learn how to find inference on each of these, okay? And do a hypothesis test, do a confidence interval, that sort of thing. Next chapter, we're going to look to see, is there a difference between the upper class smoking rates and the current and the lower class smoking rate. But for now, we're just focused on one of those two. So yes, they need confidence intervals and inference techniques. But you saw this way back when, right? Where it was like, are they independent? Do you have reason to believe that there's an association between the two? That sort of thing. Okay, so you have the sample proportion. All right. So the sample proportion is the number of successes, p hat, divided by the total number of individuals pretty much that, right? The number of successes that you have in some group divided by the number of individuals in the sample, or N, I guess you could say. Okay, and again, successes in this case pertains to the event that we're interested in, right? So a success could be a negative event, like, I don't know, cancer, incidents this is not a positive outcome, right? No one wants to get cancer or be diagnosed with some kind of illness. But if we're talking about that, for our purposes, it'll be called a success. Okay? And let's see here. Others could be, if you're talking about losing money, right? No one likes losing money, but if we're talking about that, then that's that. So you may see me use the term success and failure. You may also see me use the term success and non-success. Okay, so success and failure, or success and non-success. Those are common terms that I'll use here and there. So I might use failure and non-success interchangeably. Yes, ma'am.
What is failure or non-success?
It's just the complement. So if we're talking about people who smoke, then the failure is the non-smokers. Okay. If we're talking about people from the lower class, then that's the success. Then the failure is upper class or middle class. So the other events. All right, so again, hey, dun, 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 dun. What is the proportion of upper class volunteers who currently smoke? I'm glad we asked that question earlier, right? So that was, let's see here. Go back a couple slides. $51 out of 211 from a previous slide. We talked about how we got that. Can we compute a confidence interval for this estimate? Eventually. Based upon this survey, do we have significant evidence that the majority of persons from the upper class do not smoke? Well, 51 out of 211 is less than 50%. 24%, 24.2%. Okay, so here's a good example. So if p hat equals 0.2417, and that's the percent who smoke, and that's what we're talking about, then the non-smokers would be 0.7583. So let's see here. Do we have enough evidence that the majority of persons from the upper class do not smoke? Well, if 24% do smoke, according to our random sample, so to speak, and 75%-ish don't smoke, then we have pretty good evidence so far, but you guys are smart enough to know that we have to do a confidence interval, we have to do a hypothesis test, that sort of thing. We can't just go and say, well, 75% is bigger than 50%, and we're in the clear. So for chapter 20, we are going to try to find information out about P, the true proportion. We're going to use our P hat to get us started. And then we're going to kind of create some confidence intervals and some test statistics. And you can bet your bottom dollar that there's going to be some kind of p hat plus or minus something, right? Yes, ma'am?
I was wondering, why are we unable to assume that 75% are non-smokers if 2 of them are just smokers and non-smokers?
We can still assume that, but again, this is a random sample of 211 people. So now we're trying to infer upon an entire population. So we can say, yes, 75% is our point estimate in this case, but we're now testing the hypothesis that in general, for every single upper class person out there, is this true? We only have 211 people so far. So it's the whole thing. We have to kind of do a confidence interval, hypothesis test, that sort of thing.
The 211 people?
Well, we're doing now we're trying to make a inference on the entire population of all upper class folks in the world.
Oh, okay.
So we haven't talked to every single upper class person, right?
Just the sample.
Exactly. The sample is 211. We're trying to now look at the broader picture. But yes, you're right, obviously, right? If we're talking about the sample only, then yes, it's more than 50%. Okay? So in chapter 6, we would just start with these numbers and be done with it. Now in chapter 20, we kind of go and broach the broader issue. Okay. And then you can guess that the test statistic will probably have something in the denominator. It'll probably have something behind the subtraction sign and something in front of the subtraction sign, where we're going to take a number minus something divided by something else. And in fact, it'll probably be p hat right here. So p hat minus some number divided by some other number will probably give us a z or a t, that sort of thing. Okay, so then way back when, chapter 11, which was on the midterm, okay, there was a question where it was asked, like, hey, what's the chance that one person had this situation happen to them? Then you have a random sample of 45 people, right? Oh, you've moved on to your next exam. I know. Anyway, that concept from the central limit theorem lays a foundation for chapter 20 when we look at proportions. Okay, so here we go. Let's see here. Yeah, a random sample of size n from a population, that's p hat. We got that. Okay. And then very straightforward, the mean of the sampling distribution is just p. That's what you expect it to be. And then the standard deviation is going to be that character. We couldn't quite get it all in one line. And then, of course, when we get down to the mathematics here, we get a mean and a standard deviation. So again, for those of you filling out, it's just mean and standard deviation. All right, so here we go. Same kind of concept, right? So we have p hat plus or minus z times something. Oh, okay. Well, here's the z-score. Here's our standard error. And here's our point estimate. So before it was like x bar plus or minus z or t times standard deviation or radical n. But now all of a sudden, we're going to go down a little further and see it just kind of, let's see here. go. So now there's your point estimate. There's Z, and then here is the standard error. So if we don't know the true proportion P, we use our point estimates from our data to give us a better gauge of it, I guess you could say. So, so that's our standard deviation in the beginning, radical P times 1 minus P over N. And then we use our point estimates, P hat, to then fill this in. And so this, you get from a chart. This is from the data. That's from the data. So you can get a confidence interval. So yes, guess what? We can do confidence intervals for proportions now. Okay, and so then here's a brand new formula, but yes, it'll be given to you on an exam or a final, what have you. Okay, and we will use Z. That's probably what's most important for you guys in this class, is that we're going to use Z when we do it percentages. So anytime on a test or a homework problem, I ask you about a confidence interval for percent, forget the T-chart. It's got to be Z in this case. So then there's the Z score, and then of course here's a condition here. You want to assume that you have at least 15 successes and 15 failures. So it can't be too small. That's the whole point. So you figure your sample size has to be somewhere at least 30. That makes total sense. So back here, when we got to this slide, P hat plus or minus what? Well, it eventually became that. Okay, so some condition that we need to kind of keep in mind for this new and exciting situation. Do we have a random sample from the population? If not, is it representative of the population, or is it a randomized experiment? You can pretty much assume random sample going forward. Okay. The next question, of course, is it small enough to help us with the independence assertion? So that's going to be good. And then the last one is, of course, is it a large enough sample? Okay, and Mr. Decker, are you back? Okay, Mr. Decker. Okay, I called on you earlier, but you're back now, which is most important. Okay, so it says here, for one of our conditions, do we have at least blank successes and blank failures? How many do we need of each? According to our notes, or even according to this slide. It rhymes with 15. 15, good job, good job, good job. All right. Do we have at least 15 successes and 15 failures? I'm going to bring a roster and then just start calling my folks. Yeah, I guess we'll are we going to get out early? No, I can't do that. That's just heretical. All right, so we'll go to one more slide. All right, so let's construct the 90% confidence interval for the true proportion of persons in the upper class who smoke. Recall from earlier that this was a random sample of 211 persons, of which 51 were current smokers. We did that earlier, and we had, I think it was p hat equal to 51 out of 211, which is like 24%, right? 24.17. Okay. We have time today, so that's good. So I'll take my time going through this exercise, and I'll try to write a little bit neater for you and make it a little bit more orderly so you can follow along. So here we go. All right, so wrong one. Okay, so let's see here. Let's use different colors. Pen. So whether you like smoking or not, whether you think it's healthy for you or not, we're talking about smokers from the upper class. So that's going to be a success for our purposes. Okay, that works for me. All right, so then the next one, we want to think about all right, so given information. Okay, so again, given information for us is that we have, I'll do the condition check in a second. That going on, and notice how I'm going out to 4 places here. You could go out to 2, very, very dangerous. Don't round with these percentages until you get to the very end and then go 3 places. So let's keep 4 significant digits as we go through the process and then 3 at the very end. Okay? Okay, so there's those. Do we have information that's from a random sample? Yes, we do. Okay. Is our sample small enough relative to the entire population of folks from the upper class? Well, the Okay, so the number of people from the upper class is arbitrarily large, so that's not an issue for us in this case. And then here's a condition that's probably more prevalent for us here. Is our sample large enough? That's where we have to have that 15 that Mr. Decker talked about. So we need at least 15 successes, and we need at least 15 failures, which is people who aren't successes or non-successes. Well, let's see here. We have 51, right? Yep. 51 successes from right there. And then we have 211 minus 51 non-successes, which is 160. So yes, 51 is bigger than 15. Yes, 160 is bigger than 15. So all these guys check out. And now I pause for station identification. Okay. Try not to write too small, but it looks like it's kind of small in the corner. It's a random sample. There is an arbitrarily large number of people from the upper class. Yes, ma'am. Oh, okay. Good question. We would do 211 by 20, and then obviously there's more than 4,000 plus people. Yeah, so if we do, we'll just go ahead and do that real quick, okay? So her question is, one of the conditions was you multiply by 20, right? So let's see here. If you have 211 is your n, multiply that by 20. What's that? 4220. Okay, so we can say that there's okay, so that kind of works out either way. So one of the criteria was it has to be at least 20, right? So 20 times your sample size of n is 4220, and I'm sure that there's even more than 5,000 people from the upper class in Columbus, let alone Americans, I guess you could say. Thank you for bringing that to my attention. Thank you. Okay, so we are almost ready. No, we're not ready for that yet. Okay, so now maybe I'll try and make some room here. Given information also. P hat is 0.2417. 1 minus P hat is this number. It also says a 90% confidence. Do you guys recall which critical value corresponds to 90% confidence? 1.645. Very good.
No, 1.966.
Right. So 1.96 is 95, and then 2.57 and change, and then this 1.645 is 90%. So the formula, yeah, we're going to be just fine, is P hat plus or minus some z-score, and I'm going to write this out the way you would type it in your calculator. So I'm going to write it out laterally, okay? Radical parentheses, open parentheses, 0.2417 multiply 0.7587 divide 211. And if you want to do a closed parentheses, you can. That's a little small in the back. Your name, sir, in the back with the purple shirt? What's your name again? Huh? George? What's going on, George? Can you read that, George? You don't? Oh. Well, I couldn't pinch it, right? So, trust me, George, it's going to be in the notes, all right? It's the square root of radical 0.2417, 0.7587, 211. So p hat is 0.2417. I'll make it a little bit bigger this time for you, George, okay? So 0.2417. We had this debate, but not really much of a debate. 1.645. Yes. Ah. Yes. Some of you guys are just licking your chops on that one. Okay. So yes, thank you very much. We'll do a quick manual search and replace. Okay, and again, because we have time, right? So I'm gonna slow it down. Okay, what I want you to do, and we have time, so we can kind of talk this through a little bit. Go ahead and enter this into your calculator. Oh, it's Thursday. I'm like doing it. Please do it. Okay, I brought my calculator, so I'm not gonna just let you guys do it, and I'm not gonna have the fun. Now, if you're very skilled, you can do the whole expression in one swoop. But I'm just expecting you to do the margin of error in one swoop. So do 1.645 square root 0.2417 multiply 0.7583 divide 211. Close parenthesis. Do it all in one fell swoop. It should work out. Okay? And let's see here. Who can raise their hand and tell me the margin of error that you got? It should be 0.0 something. Come on, be bold. Yes, sir, in the back, your name again? Mr. 0.048, that's correct. What's your name again? Jeff? Okay, yeah, Jeff. I got 0.048. Yeah, I agree. Now, let me, again, this is, remember I was at Columbus State, so we had smaller class sizes, and I would kind of walk around the classroom and make sure everybody got it all right. But my point is this, with this case, if you do it right the first time and you feel more confident with it, that saves you a ton of time compared to an exam where you have to do it step by step by step. Multiply this, divide, square root, and so forth. And then this is the margin of error. So it's like a true give or take. So back to our original issue, right, about the 25% or whatever, we're saying from our data that about 24% of people from upper class smoke, give or take 5%. So based upon our random sample, we can make an inference about all those upper class folks who walk around like that. All right? So let's see here. So 0.2417 plus 0.048, 0.2417 minus 0.048. should get you to a range of something like 0.193 to let's see, 0.2417 plus 0.0485, if you will. And 290 or so. Something like that. Let's go at 0.29. Okay. Okay, so again, now let's think about that for a second. 24%, give or take 5%. Well, 24% plus 5% is 29. 24% minus 5% is 19. So we're basically saying, I think I got room at the bottom. Ah, 90% confident. Okay, so I guess having it in this format makes it easier for you when I start writing at the very bottom. So we're 90% confident, that's the same kind of language from before, that between 19 and 29% of upper class people smoke. Okay, or that the true percent of people who smoke upper class is between 19 and 29. Please be careful with how you put things in the calculator under the radical. I think that's a good stopping point, and you got out 1 minute early. Okay, good.